is continuation of lesson 1.3 example, and this is example 1. We want to solve for x, and here we have 3 over x is less than 5, where x cannot be equal to 0 because it'll give us undefined. So we don't know what x is. It could be positive or negative. So we separate x into 2 cases. Case 1 is where x is positive, where x is greater than 0. Case 2 is where x is negative, where x is less than 0. Case 1, we'll assign a set sub 1 to that. Case 2 will set S2. So when we're finished, the solution is going to be the union of set S1 and S2. Okay, so we start with writing set S1 is a set of x, values in set x, such that 3 over x is less than 5 and x is greater than 0. Set S2, x, all values in set x such that x over 3 is less than 5 and x is negative, or x is less than 0. So we've established our 2 sets here. So now we look at x is an element in set 1 if and only if, going both ways, 3 over x is less than 5 and x is greater than 0. So first thing we solve for x, multiply x to both sides, and we get 3 is less than 5x, and x is greater than 0. Divide by 5, and we get 3 over 5 is less than x. Since x is positive, it's not going to switch to inequality sign. So 3 over 5 is less than x, and x is greater than 0 if and only if x is an element in set S, 1. So in this case, we go ahead and write out the number line, and we have 0. And 0, since x is greater than 0, you have all elements going greater than 0. And since x is greater than 3 over 5, you have that. So you look at where the overlap is, and it's going to be at greater than 3 over 5. So that's our solution. So 3 over 5, so our solution for set S1 is 3 over 5 to infinity. Okay, so now we look at set S2, and x is an element in set S2 if and only if 3 over x is less than 5 and x is negative. So when we multiply x to both sides, because x is negative, it's going to switch that inequality sign. So this time the inequality sign switches. Last time it didn't because x was positive. So now we divide both sides by 5, and since 5 is positive, it doesn't affect the inequality sign. So we get 3 over 5 is greater than x, and x is less than 0. If and only if x is an element in set 2. Okay, so this time with this one, since we have 3 over 5, draw this out. Here's a number line. Here's 0, and here's 3 over 5. We're saying 3 over 5 is greater than x, so it's going to move that to the right. Oh, I'm sorry, this is going the other way. Here's 0, here's 3 over 5. Since x is less than 3 over 5, it's going to the left. That's better. For 3 over 5. And x is less than 0. But since the overlap is here at 0, the solution is going to be from -infinity to 0, because that's where both conditions are satisfied. So our solution here is going to be S2 is -infinity to 0. And since we said before that our final solution, our complete solution is S1 union S2, then on the number line, this is S1 greater, that's what we had here, 3 over 5 is greater than infinity, so that's that way. And this one here, S2 is 0 is less than infinity, so S1 union S2 is -infinity to 0 union 3 over 5 to infinity. Okay, so we're going to have another example, and to give you more practice with that. And so that's the end of this video.